Alrighty, now we've covered mean absolute error. We're going to have a look at mean squared error. So we'll go here. Actually, we'll make a little heading as usual because we're keeping our notebook nice and clean. So mean squared error. Wonderful. And then we're going to go mean squared error. Now you might, based off what we've looked at with mean absolute error, you might be able to deduce how we might calculate mean squared error. If not, again, perfectly fine. So if we come down here, so from Scikit-learn dot metrics, import mean squared error. Wonderful. And so we're going to do it basically in the exact same way. So MSE equals mean squared error, except this time instead of using absolute, we're going to be using squared. Then we're going to take the Y test labels, and because we've already made predictions up here, Y preds, we could make them again, but we might just reuse the values here. Y preds. Actually, for completeness, what we might do is just the Y preds equals model.predict, and we're predicting on the X test data because we want to compare our predictions to the Y test data. Then we're going to have a look at MSE. 9.242. That's a little bit higher than what we got with mean absolute error. Well, that's because MSE, or mean squared error, I should put MSE in here, right? Because there's so many acronyms these days. MSE will always be higher than mean absolute error because it squares the errors rather than only taking the absolute difference into account. So if we come up here and have a look, this data frame would be the exact same here. So what mean absolute error does is it takes these values and it turns negatives into positives, adds them all up, and then finds the average of it. What mean squared error does is it takes these values, squares them, then adds them all up, and then finds the average, hence the mean squared error. So that's why the squaring part, squaring these numbers, will lead to a higher number here. Actually, we might just do it. So let's see if we can. Calculate MSE by hand. Now this is dangerous, right? We're going off the record here. Calculate MSE by hand. So all we have to do is take the differences here. So actually df differences, we need to square that. Actually, might do here. So MP, is it MP square? Yeah, MPSQ square df differences, and then should be able to call the mean on that. So actually, let's put that in brackets. Can we do that dot mean? Right. Squared equals that. What does squared look like? Okay, so this is going to take this column here as squared. Now, to calculate the MSE, we just need to take the mean of squared. Beautiful. There we go. See? That's how we calculate the mean squared error. That's it, right? We've covered mean squared error, we've covered mean absolute error, and we've covered R squared. Now, the next logical question is, and even if you aren't asking it, is which regression evaluation metric should you use? So we look here, we'll come back to the keynote. So R squared is similar to accuracy, right? It gives you a quick indication of how well your model might be doing. Generally, the closer your R squared value or coefficient of determination value is to 1, the better the model. But as we've seen before, R squared doesn't really tell us exactly how wrong our model is in terms of how far off each prediction is. For that, mean absolute error gives a better indication of how far off each of your model's predictions are on average. So that's when we saw this one here, right? This is how we saw, on average, each of our model's predictions is about 2.12 away from what it actually should be, whether that's positive or negative. And so we come back here. Now, it can get a bit confusing which to use between mean absolute error and mean squared error. Well, because of the way mean squared error is calculated, we saw that by calculating it by hand. We squared the differences and then took the mean, right, instead of just taking the absolute differences. Because of how MSE is calculated, squaring the differences between predicted values and actual values, it amplifies larger differences. So you could imagine if we had a difference of, say, 10 and we squared that, right, that's going to be now a difference of 100 and we're taking the average of that. So let's say we're predicting the value of houses, which we are. You want to pay more attention to mean absolute error when being $10,000 off is only twice as bad as being $5,000 off. So that makes sense, right? But pay attention more to mean squared error when being $10,000 off is more than twice as bad as being $5,000 off. You might think, well, it's not really if I double $5,000 to $10,000. So this is kind of another way of saying is that when bigger errors are bigger than smaller errors, right? So if we're $10,000 off, and that's way worse than being $5,000 off, we want to look more to mean squared error. Long story short, a little tidbit here is for regression models, you want to minimize mean squared error and minimize mean absolute error while maximizing R squared, right? So does that make sense? Minimize mean absolute error, minimize mean squared error while maximizing R squared. Whew. Now that we've covered a handful of some of the most useful and common regression metrics, we come back here, we see that there's still a fair few more that we could have done, right? So that's a little challenge to you, is to dive into model evaluation metrics, but the ones we've gone through are more than enough to get started. You might be thinking, hold on, we haven't even used the scoring parameter, which is what we talked about 5 or 6 videos ago. Well, now that we've covered some of the, as I said, some of the most common and useful regression and classification metrics, we can finally take a look at the scoring parameter, which is what we'll do in the next couple of videos.